The thing that makes number 8 a little bit tricky is that our index k starts at 3, which means we can't apply any of the formulas we have at our disposal directly. In this video, we'll look at two options for how to approach a problem like this. The first of these options is to rewrite this summation with a new index which does begin with 1. The first of these options is to create a new index which does begin at 1 rather than 3. And I'm going to give this a new name. We're going to call it j, and we're going to let j equal k minus 2. By doing so, we get that when k is equal to 3, j is equal to 3 minus 2, which is 1, which is what we want. And when k is equal to 120, which is our upper bound, j is equal to 118. Okay, it's also important to note that if j is equal to k minus 2, we can equivalently write that as k equals j plus 2. So now we get a nice way of rewriting our sum. Our sum, which was originally from k equals 3 to 120 of k plus 7, is now going to become the sum as j goes from 1 to 118 of our k gets replaced by j plus 2, all plus 7. Okay, so if we do a little bit of simplifying there, we have the sum rewritten with a new index which does begin at 1, which will allow us to use the formulas that we worked out in class. Given that there isn't anything to distribute, we can drop the small parentheses around j plus 2 and then combine like terms to get the sum of j plus 9 from j equals 1 up to 118. Okay, now we're almost ready to apply our formulas to get an answer. We just have to do one more step, which is to take this summation and split it into two sums. So we're going to have the sum of j, as j goes from 1 to 118, plus the sum of 9, as j goes from 1 to 118. And at this point, we're ready to apply our formulas. For the first sum, our n value is 118, so we get 118 times 119 all divided by 2. For our second sum, we're just adding 9 to itself 118 times, which is the same as 118 times 9. Simplifying a little bit, we can divide 118 by 2 to get 59 times 119. 118 times 9 is 1062. So with just a little bit of arithmetic, we get our final answer. For 59 times 119, we should get 7021 plus 1062 gives us 8083. Okay, and that's one option for solving this problem. Our second option is to take the sum as k goes from 1 to 120 of k plus 7 and break it down in the following way. We can say that the sum as k goes from 1 to 120 is really the same thing as the sum as k goes from 1 to 2 of k plus 7 plus the sum as k goes from 3 to 120 of k plus 7. And since we have in this expression now the sum as k goes from 3 to 120, we can solve for that and see what we get as an answer. So treating this entire sum as one big term, we can subtract it over to the other side, thereby solving for the sum as k goes from 3 to 120. Like we did before, we'll take the first sum and split it into 2 so that we can apply our formulas. So we'll have the sum as k goes from 1 to 120 of k, Add to that the sum as k goes from 1 to 120 of 7, which is really just 7 times 120. And then for the second sum, since there are only 2 terms, we might as well just calculate those manually. In other words, plug 1 in for k. You get 1 plus 7, plug 2 in for k, you get 2 plus 7, and then you don't have to bother with the formula at all. All that's left to do now is simplify. We take the first sum, we use our formula, which says that the sum of the numbers from 1 to 20 is 120 times 121 over 2. Since we're really just adding up 127s, we can say that that sum is going to be 7 times 120. And then we've got minus 1 plus 7, which is 8, and 2 plus 7, which is 9. And after a little bit of simplification, we end up with 8,083, just like before.